Alright, in this next section, 3.3, they're going to talk about the unit circle. And that unit circle is just going to give us another way to answer the trigonometric question. So this will be a nice review section. And so in section 1.3, we define the 6 trig functions where the domain was a set of angles. I'm sorry, in section 1.3. And in standard position, in the advanced math courses, it's necessary to define the domain to be all real numbers. And the way that we do that is by utilizing the unit circle. So what is the unit circle? It's a circle where r is 1. And so keep in mind, arc length, s is equal to r theta. If r is equal to 1, then theta is equal to s. And that's the definition of a radian. So the nice part about this is when you're on the unit circle, what's the equation of the unit circle? X squared plus y squared is equal to 1, right? A circle with radius 1. We can define the sine of an angle here, which they're going to use a different letter. They're going to replace the theta with s. Maybe I should as well, so as we go down it doesn't confuse you. Theta and s are the same thing when you're on the unit circle. So if this is s, the sine of s is just equal to, this is the point xy, the y coordinate on the terminal side. The cosine of s is equal to x, and the tangent of s is just equal to y over x. As you know, it's sine divided by cosine. And so it's very nice to have these associations that sine corresponds to y, cosine corresponds to x, and the unit circle just stresses that. Because remember what it was. It was y over r. But what's r for us now? Well, r is just 1. And that's why you're just coming out with y. So if you feel like we're learning something new, we're not. We're saying, what if the radius was just 1? If you were dealing truly with the unit circle, then you just get these nice relationships coming back out. The important part about all of this is that the angle is a real number and therefore utilized for us. Now, these other ones should be nice. Cosecant s is going to be 1 over y. Secant s is going to be 1 over x, and cotangent x is going to simply be x over y. And if I come down, they define all of those. Now they go a little bit farther, right? They make sure we don't divide by 0. And then they start talking about, now that we can consider these functions, right? Functions with real number inputs and real number outputs. We find that the domain of the sine and cosine is anything that you want. You can do anything that you want. But if you start to go to the tangent and secant, let's take a look at why they group those together. I'm going to come in here and erase these underlines that I put in here. And I'm going to use my highlighter. They're focusing on tangent and secant. Now, why would they pair those together? Look who's on the bottom, x. We're going to have a problem whenever x is 0. Well, let's take a look at, I can use this axis down here. Where is x 0? Apologize, that's not where x is 0, that's where y is 0. So let me erase that. Where is x 0? Right, actually let me use this more thin one. Right here. Okay, that's too thin. Right here. That's on that axis. Now what are the angles on that axis? Let's look at them. We'll put them in black. 3 pi over, I'm sorry. This is 3 pi over 2. This up here is pi over 2. So we're going to have a problem at pi over 2 and 3 pi over 2. And that's what this is. They're all the odd pi's. The 2n plus 1 ensures that that number is odd. 1, 3, 5, 7. That's what the 2n plus 1 ensures. And n can be any number. So it could be -1 or -3. But it's going to be odd. Now, why pair cotangent and cosecant together? Let's take a look at that. We'll highlight those in red. Look who's on the bottom, y. Where's my y 0? Right here. So where are we going to have a problem? At any pi. Remember what this is. Let me come in here in black. This is 0, 2 pi, 4 pi. This is 3 pi, 5 pi, 7 pi, negative pi, negative 2 pi. Any pi that you have, any integer pi that you have, we're going to have an issue with cotangent and cosecant. So that's why they have limited domains. But they're defined everywhere except for those even multiples of, those odd multiples of pi over 2 and any multiple of pi for the other. So hopefully that makes a lot of sense. As you come here, you want to look at this as more practice with, right before an exam, with finding the trig values of a particular function. And so let's do this. So we have talked already about reference angles and other things like that. So we just need to know where we're at. 4 pi over 3. Where is that? Well, that's pi over 3 beyond. So that's a third quadrant angle. Sine in the third quadrant is negative. So we get that out right away. And sine of pi over 3, ideally through memorization, square root of 3 over 2. I know that sine of pi over 6 is 1/2, so then I know sine of pi over 3 is negative root 3 over 2. Cosine. Okay, cosine of the exact same angle. Well, that's still in the third quadrant, so I'll use this same picture that's there. Cosine in that third quadrant, all students take calculus, is also negative. And cosine of 4 pi over 3, cosine of a pi over 3 angle is 1/2. And we're done. How about negative 9 pi over 4? Let's figure out where that is. Well, that's really close to 8 pi over 4, which is 2 pi. So I'm going backwards 2 pi. There's my 8 pi over 4, and I'm going pi over 4 more. I'm right here. And let me come in here and erase my circle, and then put in here in blue, I'm off by pi over 4. I'm in that fourth quadrant. Okay, all students take calculus. Oh, my answer is negative because it's a tangent. And I remember that the tangent of a pi over 4 angle is 1 because it has a slope of 1 in there. Okay, from the memorization piece of it. Sine of 11 pi over 6. Step number 1, what quadrant are we in? Okay, 11 pi over 6 is really close to 12 pi over 6. Why did I pick 12 pi over 6? Because 6 goes into it evenly. How many times? 2. I'm in the fourth quadrant, pi over 6 before making a full rotation. All students take calculus. Awesome. I know that I'm negative, and what am I? I'm negative 1/2 by memorization that sine of pi over 6 is 1/2. Secant of 23 pi over 6. Now secant corresponds to cosine. So this is 1 over the cosine of 23 pi over 6. That's how I personally would think about it. I would think of the closest multiple of 6 to 23, and that's 24 pi over 6. Well, where's 24 pi over 6? Well, that's 4 pi. Where is 4 pi? 4 pi is right here, but I'm not quite there yet. I'm backed off pi over 6. So notice 11 pi over 6 and 23 pi over 6 end up in the exact same place. Well, I need the cosine of that. All students take calculus. Oh, it's going to be positive. So this is going to be positive. I'll just put that positive in there. And cosine of pi over 6 is root 3 over 2. So this is going to be, I'll put my answer down here. The answer to this one is going to be 2 root 3 over 3, but positive. Why positive? We're in the fourth quadrant. How do I know we're in the fourth quadrant? Because we're almost to 4 pi. And so when I know 4 pi lies right on there, right? And so do you. And so we should be able to do these without the use of a calculator. If you give me the decimal answer for 2 root 3 over 3, I will mark it wrong. You need to give me the exact answer when it's nice like that. When it's one of the memorized ones, you have to give me the exact answer. And I'll stress that in the exam as well. You'll see that written. Give the exact answer to the following. It won't just say evaluate. Sound all right? So we get 2 root 3 over 3 out of that. Cosecant, well, that's 1 over sine. Now, I do that personally so that I can put my mindset into only memorizing just a few things. Okay, so 13 pi over 3. Closest one is 12 pi over 3, which is 4 pi. And where would I be? I would be beyond that. So here's 4 pi right on the axis. I'm going to be beyond that pi over 3. I'm in the first quadrant where everything's positive. I ask myself, what's the sine of a pi over 3 angle? And I come up with root 3 over 2. Got to flip it for 2 root 3 over 3 again. So both of those were 2 root 3 over 3. Cotangent of negative 5 pi over 6. Well, where's negative 5 pi over 6? Really short of negative 6 pi over 6. So it's down here by pi over 6. All students take calculus, so it's going to be positive in there. So I'm going to just note that it's positive. If you left it off, that's fine. It's normal. And I got to think about cotangent. Cotangent is cosine over sine. Cosine of pi over 6 is root 3 over 2. Sine is 1/2, and if I divide those two, I'm going to get a root 3 out of there. Nice, I was able to come right back. I'm going to get a root 3 out of those guys. And then secant of pi over 2. Secant is 1 over cosine. So let's remember where pi over 2 is. We know it's right there. Cosine corresponds to, let's remember, maybe we remember, cosine corresponds to x, right? And so what's my x distance? Well, my x distance is 0, so this is 1 over 0, or this is undefined coming through there. So nice ways to get all those answers. Now these two are calculator problems, but we want you to be able to come up with the right calculator problem. And so actually the first one is a calculator problem because we don't know this sign. So on your calculator you should see a sine inverse one. It's in the first quadrant, which is where sine inverse is going to spit out on. But they just want you familiar, I think, where this button is and why they're assigning that. So you'll find that button, and you'll take the sine inverse and make sure that you are in radian mode, right? Because, and that's what this says, make sure you're in radian mode if you're going to use a calculator, because they're wanting the solutions to be S. They're wanting to be radians between 0 and pi over 2. So I'm in radian mode. I'm going to go get my sine inverse. I'm going to type in 0.3210, and I'm going to hit equals, and it's going to give me a 0.32678. So I'll do 0.3268. If you did 0.33, fine. 0.327, no problem, right? Full credit given for that. This is the better one, though. This is the more one that's going to be on the exam. Find the exact value of that. So what do we want to do? First thing we want to know is that we are in the fourth quadrant. If you name any other angle other than a fourth quadrant angle and represent it between 3 pi over 2 and 2 pi, you will miss the problem. The next question is, who's the reference angle that gives you a tangent of negative root 3 over 3? And so you can go back in your notes and look. You can go to the chart, right, that said sine theta, cosine theta, tangent theta, and you'll find the one as we did pi over 6 to be 1/2 root 3 over 2 and root 3 over 3. It's a pi over 6 reference angle because you took the time to memorize that the tangent of pi over 6 was root 3 over 3, or at least memorize the sine of pi over 6 is 1/2. Cosine then would be root 3 over 2, and if you did sine divided by cosine, that root 3 would end up on the bottom, and your tangent would be root 3 over 3. Well, we have a pi over 6 reference angle in the fourth quadrant, so what am I going to do? I'm going to take 2 pi and subtract away pi over 6. What is that? That's 12 pi over 6 minus pi over 6. That's how the book is going to tell you it's 11 pi over 6. That is the answer to that one. And so some good problems right at the end. But actually, the power of this section is good reinforcement of trig right before. Another way to look at it through a unit circle. But really the stress there is that we can deal with real numbers. But the big part is you get more practice with finding the sine, cosine, tangent, and the other three for any one of our special angles.